Yes, we're still under manometer calculations. We did some calculations on the YouTube type. Now, I wanna try to do other calculations on the next one, which is the inclined tube. Okay. So here what I did, I just drew the sketch. You see there. So the inclined tube, there's the sketch. We have area 1 and area 2. Then this is L, which is dropping. That's the level which the liquid drops. And H is the rise height. Then D is your distance. So the liquid went from this point to the other one. Okay. Then you can explain from there's a triangle here to be made. Alpha is your angle of inclination, the one you see there. From the triangle, you can say that H over D is equal to sine alpha. We call that equation 1. Okay. Then we can find D from this equation, from equation 1, or H. Let's find H. H is equal to D times sine of alpha. We call that equation 2. Okay. Then remember that the volume drops in A1 is equal to volume rise in A2. So the amount of liquid that is placed in this tube will be the same as the one we rise on the other tube. With that, we know that a volume in A1 will be equal to area 1 multiplied by L, the height, the drop in height, L there, and volume in area 2 or in A2 will be equal to A2, which is area 2, multiplied by D, which is the distance there. Okay. From there, we can substitute and get L. L is equal to area 2 over area 1 multiplied by D, the distance. We call that equation 3. Okay. Then we need to find the differential pressure. Remember looking for differential pressure. What is the differential pressure equal to? Differential pressure is equal to P1 minus P2. It's rho times J multiplied by L plus H. Okay. So we find the differential pressure by adding both the drop height and the rise height. From there we have, remember guys, now we can substitute L and H. If you go on top, we say that H is equal to D sine alpha, and L is there is area 1 over, so area 2 over area 1 multiplied by D. So now we can just substitute in this equation. So then there we go. Our final differential pressure P1 minus P2 is equal to rho J, area 1 over area 2 over area 1 multiplied by D, which is our L, plus D sine alpha, which is our H. Then we can take out D. Then this is our final equation. You guys need to remember and also transfer to your kid, to your children, or remember it until you die, or as long as you'll be doing engineering. It will be helping you. That was inclined type. Then there is another type of manometer, which is the well or cistern type. Okay, it's well. This is the next one. This is S. It's a same type or well type. So this is the sketch. Again, we have P1 coming there and P2 coming this side. If I can go back on the inclined tab, and also remember to indicate P1 and P2 on the sketch. You can't see the sketch. You can use this one here. So there is P1 coming there, the inclined tab, and also P2 on the other side. That's how I found the differential pressure. Okay. Then on the wells type, we have P1 coming there and P2. This is area 1 and area 2. Okay. Then at balance, this is how the liquid will be. The liquid will be at the same level in both tube. But if now we apply pressure on P1, the liquid will drop. Let's say the liquid drops up to this height, which we call now L drop. Okay. Then on A2, the liquid will rise. It will rise, and the distance we call it H rise. Okay. Then because the liquid rise, that means there's differential pressure, and that also means that P1 is greater than P2. Therefore, we can find the differential pressure, which is P1 minus P2. It will be equal to the pressure in here minus, it will be rho J H plus rho J L. So we find the pressure using this height here, the drop, plus the pressure using the rise height. Putting together, we have that equation. Then we can take J rho out. Then we have rho J multiplied by H plus L. We call this equation 1. Again, remember that volume drop in A1 is equal to volume drop in A2. Okay. So volume drop in A1 equal to volume drop in A2. For that reason, we can come up with these equations here. The next one. So that volume drop on area 1 will be A1 multiplied by L. What is L? Is the drop height, and then this is equal to volume drop in area 2, which will be given by A2 multiplied by H. H is a rise. Then we can find L. L is equal to area 1 over area 2 multiplied by H. We call this equation 2. We say that this one, which one we call equation 1 here, we call this one equation 1, and the other one here is our equation 2. If now we can substitute equation 2 in 1, it means we substitute L here in 1 by this formula. We can come up with this last equation, where now your P1 minus P2 will be J or rho J H multiplied by 1 plus area 1 over, so multiplied by area 2 over area 1. This also to remember. Thank you, and good luck to all.